So, hey, today's lesson is going to be on hardness again. This is a ruby, a rather large ruby. And you can see the crystal structure, right? This is the... uh-oh, man, I just got a rock up my sleeve. Nothing up my sleeve. I did have something up my sleeve. All right, so, and these are opal, various flavors. This one's Lightning Ridge, and this one's from Ethiopia. Okay. This here is what people call quartz crystals. Okay, and you know, it's been worked. Somebody came along and polished up the sides, made it all pointy, and gave it, you know, an even X and Y axis. And hexagonal means the hexagonal crystal system means two even axes and one long axis or one short axis, one of the other. And rubies very often come in perfectly hexagonal crystals that are kind of short, tabular, or long and barrel shaped. And they have a pretty obvious crystal structure. Quartz has a very obvious crystal structure, but it's rarely even axes going this way and that way. It's long and it has 6 sides, but that does not make it part of the hexagonal crystal system. Okay, it has 6 sides, but that doesn't mean that it's part of the hexagonal crystal system. Okay, so not everything you read in books is true. The first thing I'm going to do here, and I'm going to turn that over, and we're going to see this side's nice and shiny. Look at that. My supposed quartz crystal, quartz is supposed to be 7 on the Mohs scale of hardness. Ruby is 9 on the Mohs scale of hardness, and ruby should be able to scratch quartz, but quartz should not be able to scratch a ruby. Okay, and what we have here is a scratch from my piece of quartz. Okay? Which means this is harder than the ruby. Otherwise, it couldn't scratch it. Like trying to scratch a glass with a knife or a fork or something, right? Just skates. And what'll happen here on my opal that's supposed to be 5.5 on the Mohs scale of hardness is it just skates. And we'll blow that up, and you can see some of the ruby dust on there. But it did not scratch the, and you can hear the difference. On the ruby, it kind of drags, and there's some friction going on. And it's not because the ruby's rough and this is smooth. I can do that on my Ethiopian opal too, on the rough part, and there it is. There's a scratch, but the dust comes right off because what happened was I wore a little point off of my 10 on the Mohs scale of hardness piece of quartz crystal that's not actually quartz. It's not silicon dioxide, and neither is this. Okay? Both are supposed to be silicon dioxide. Quartz is supposed to be one silica atom surrounded by 4 oxygen atoms. And if you've ever seen something, so if we put that silica in the middle, it would have 4 oxygen atoms around the outside. two atoms short, because three-dimensional structures have 6 things, 6 sides. And it's not just cubic boxes or, rubies. Rubies have a tetrahedron shape that is 4 triangles, triangular faces, and they form these hexagons, right? When they're all bunched together, it's like 4 of those put together. Actually, it's more like this whole thing here, and 4 of those, and it makes like a 3-sided pyramid with a triangular base. And what happens if you look at the information on quartz, the center part is supposed to be a silicon atom, and then there would be 4 things on the sides at 144 degrees, which means all of the other angles have to be, not should be or can be or might be. They have to be multiples of 144 degrees. They are not even hexagonal angles. It'd be like 72 and 36, and what we have here is a 60-degree angle, and so this would be 120, 120, and 120 for 360. When you look here on the sides, what you'll find is little squares, which are 90-degree angles. And that's impossible with a 144-degree bond angle. This is supposed to be little spheres of silicon dioxide, the impossible silicon dioxide, and it is in fact 10 on the Mohs scale of hardness. And doesn't have anything to do with silicon dioxide. We use silicon dioxide on computer chips, and it creates a 2-dimensional layer on top of a computer chip, and that's what 4 sides would do. Will give you a 2-dimensional figure. So you can't believe everything you read in a book. I'm sorry that that's true, quartz fans, but that's true.